if a router has 4 or 5 routes that all made it, they won, they're in the routing table, and then an incoming packet comes in. And this packet comes in, the router looks at the destination IP address, and then realizes, holy shnikers, this IP address, the destination address, has a match on more than just one route in my routing table. Which one do I use? That's the question that we're going to answer right now. So let's imagine we have a router and it has these 4 different networks in its routing table. One with a 16-bit mask, a 22-bit mask, a 24-bit mask, and a 30-bit mask. And because these are all different network lengths, these are all considered separate or individual routes in the routing table. So if we have Bob, the user, and Bob sends a packet, he does a ping out to 192.168.1.1, and that's the destination address. When that packet enters the router is going to have all this information on how to forward packets. And let's check this out. Does the first 16 bits, which is what this router is all about, do they match the first 16 bits of this destination IP address? The answer is yes, they do. If we take a look at the first 22 bits of this route, 192.168.0, does that match the first 22 bits? If we took that third octet to binary, we'd find that yes, it does too. And the third route, 192.168.1.0, a 24-bit network. Do those first 24 bits match these first 24 bits of the destination IP address? The answer again is yes. And this 30-bit mask, do the first 30 bits of this destination IP address match this first 30 bits? And the answer is yes, it does. Also, the router very likely has a default route, which also, if no other more specific route exists, that route could also be used, and it would be considered a match. So when we have a routing table that's in place, so all these routes won, they're all in there because they have the lowest administrative distance, or if there's matching ADs, they've got the best cost, so they're in the routing table. When a packet actually comes in and it's going to be used, what the router is going to do, it's going to use the longest match. So it's a 2-step process. Number 1, we have the routing table in place, it's all settled, no problem. And then the second question is, what is the longest match based on the destination IP address to routes in my routing table? So based on this destination IP address matching on all of these, the longest route in the routing table, I'll put them in a different color, would be this bad boy right here. And if we ask the router, hey, based on this destination IP address, which route in your routing table are you using to make that forwarding decision? It would say, I'm using this one right here. And furthermore, it could say, it's because it's the longest that matches this destination IP address. So once that packet comes into the router and the router finds the longest match in its routing table, it's then going to go ahead and use the associated next hop and exit interface associated with that longest route. And that, my friends, is the story behind how the router chooses which route entry to use if there are multiple matches at any time. And it is the longest match in the routing table. So in this video, I wanted to cover the concepts of how it's the longest match, and then I'd love it if you want to see this with your own eyes. In the next video, we'll go ahead and we'll do a lab to go ahead and implement this, reinforce it, and then verify, by George, the router is using the longest match. So I'll see you in just a moment in that video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.